Welcome back to Hard Paths with Kevin. I'm here with our Chief Analytics Officer, Kevin Mabe. If you've followed this series, you know that we, in our last episode, set up the time series analysis and why that's important. So with this one, we're going to dive in a little bit deeper to the forecasting piece of the analysis and how that can potentially help you adjust and adapt as data is coming in, as opposed to just looking into the past at what potentially went right or wrong. So Kevin, why don't you take it from here? What are we looking at?
Cool. So we're going to revisit the time series we saw last week with product two, product two revenue. And we highlighted, or at least the statistical tests highlighted, that something had changed here, where it appears that the downward trend in revenue was halted, and then it started to level off. And so let's see if I can find that. There's the graph again. So statistically, around observation number 11, which I think was 2016, around there in the middle of 2016, the decline was halted, and then things tapered off. What we're going to do today.
Another way to think of this is Nicolas Cage's career here, right?
Yeah, exactly. Oh, yeah, and we'll talk about his career during the next video for sure. But that's a good segue. So what we're going to talk about now is, let's suppose, which actually happened, and I can reveal now, that there was an intervention back here where things tapered off. The company did a better job of couponing and reaching out with those kinds of financial incentives. However, these incentives were meant to last only 2 years, and so here you're sitting in mid-2016. Now we're sitting here in mid-2018 in the trend. But then all of a sudden, for November, December 2018, when the coupon expired, that you have this low data point. So what we want to do in this video is talk about forecasting, how it can be very helpful, and put this latest data point in context. But what I'm going to do instead first is remove that data point as though we're winding back not to the last data point of 2018, but to 2018 September, October. So let's do that to show you what that looks like. Pardon me. Okay, and that's actually still there. So it's because I wrote the wrong one. We're still working out the kinks here. Okay, there we go. All right, so here we're humming along, and so back here in late 2018, there was some fear of what's going to happen next. Well, there are ways of understanding, like I mentioned in the previous video, there's ways of understanding a time series trend. There's the kind of the level of how high or how low it is, what is the direction of the trend, up, down, flat, and also any seasonality. And because we have 6 data points per year here, so each data point represents 2 months, then we have a seasonality of essentially 6. So what I'm going to do is build a very basic forecast, and I'm not going to go into the specifics of it now, but I want to show a few things. So typically what's done for forecasting is, there's a line drawn, and it's extrapolated, whether it's a fancy line, quadratic, or maybe an exponential, logarithmic. That's okay, but there's a lot more to be taken into account. First of all, you notice that there's a lot of bouncing up and down. There's a direction change, which we statistically highlighted in the last video. So what I'm going to do is build a forecast that kind of takes all that into consideration and gives us a point forecast, but as well as a forecasting interval. So let me show you what that looks like.
And while you're doing that, Kevin, does REMA mean anything? Is that a term?
Yes. So what it means is, yes, it is. It's autoregressive integrated moving average, which sounds pretty impressive. But what it really means is the autoregressive means it's identifying how this particular data point is related to the previous one, and how it's related to the previous one, and how it's related to the previous round. The integrated means that there's a movement across time. And the moving average means that when the trend or forecast is wrong for one period, it tends to be wrong in some way, shape, or form, potentially for the previous period. So it basically takes a look at this trend, and this is a very basic forecast here. It takes a look at this trend and forecasts out what we expect to see. So there's a couple things I want to highlight here. First of all, the forecast appears to have these kinds of humps and valleys. So the forecast has properly identified that there is a seasonality here of 6. where it's higher for some seasons and lower for others. The forecast also appears to maintain an upward trend that was started about here. Now, again, we took a look at it as a flat trend because we had that last data point, but I took that data point out. And then, Drew, we see these forecast or confidence limits, forecast interval, as being high and low. When you see this forecast in the confidence intervals, what stands out to you?
Well, it's a pretty big spread.
Yes.
I would say that that's surprising.
Yes, and this often surprises probably about 19 out of 20 people, because forecasts, whether they're on Wall Street or whether they are to your boss, tend to be very point specific, and therefore everything is held to that point. Are you above or below forecast? The problem with that is, from a statistical standpoint, given the fact that there's a lot of variability here, given the fact we only have X number of years of data, there's uncertainty. And so when we're putting together a forecast, we have to highlight or at least understand what is the uncertainty around the forecast. And that is what these confidence intervals show. And most of the time, they are a lot wider than people may expect. And people say, well, it could be anything. Well, it's like, actually, yes, it could be anything. Because if you were back here, who knew that the next data point could be here, compared to here, compared to here, compared to up here? It's all over the place. But what this also allows you to do is start putting incoming data into context. And so we're going to do that here. So I'm going to shift a few things so I can show you what this looks like. So we're going to graph the time series, the original time series without that last data point. We're going to graph the forecast with the confidence intervals, and then we're going to graph that last data point and put everything into context. Okay. All right. So it's hidden a little bit here. This is that last data point in December. So Drew, what do you notice about that last data point?
Oh, it's falling. Looks like it's falling just below the confidence interval, which is surprising because that was a 95% confidence range.
Right.
So I don't know what that means, but that would appear to be surprising.
Yeah, it is. And so, even given the width of this confidence interval of this very basic, very, very basic forecast, this last data point came in abnormally low. In fact, we can quantify how low this is. And in fact, in this example, it just happens to be that this is around the 5% confidence, which means, that the chance of this data point coming in this low is about 5%, which is pretty small, which means we've got a problem here. So, this forecast was built on the coupon still being in place. We knew the coupon was going to expire, and then all of a sudden it expired, and we get this new data point. So the question is it possible that that coupon had a demonstrable and statistical effect on revenue? And the answer is, could be. There's evidence for that. So, the forecast allows us to understand this confidence interval, but it also puts this last data point or any other data point after it into context. And we can actually quantify, hey boss, not only is this bad, but there's a 95 to 96% chance we shouldn't have seen this. And as a result, there's definitely cause for alarm.
So this, in my way of thinking, I used to work on Wall Street. This would be, Apple now saying, hey, we've got to revise our estimates for quarterly earnings because this is falling out well outside the forecast that we had and is going to have an impact going forward.
Yes, and in fact, let's do that. So let's suppose we've accepted the lack of coupon. Let's put that data point back in the series. So we have, again, showing here, where now we have that series. Now let's do a new forecast, and let's store it so we can show what just that one last data point does to our expectations for the future. And I'm going to not worry about the confidence interval for the new forecast just yet. Okay. So let us compare that with this, and I'm going to plot them. So the previous forecast, without that last data point, had an upward trend, pretty wide confidence interval. Now all of a sudden the forecast is flat. It still has seasonality. That's not going to change just yet. And the confidence interval is just as wide. And so if we were to now plot some of this together, just to kind of show you what this looks like. The original series, the first forecast, and the new forecast. You will see that that one data point had such an impact to the structure that the forecast prior to the coupon expiring looks in the red with the squares. With the coupon expiring, now all of a sudden we're expecting flat, and with a different confidence interval. So just a highly statistically significant incoming data point can very much change a forecast. If a dune data point fell pretty much within expectations, a little bit above or a little bit below, then you would not see this variability in the forecast. But because of that last data point, this is the effect that it had. So going back to your example, Drew, when Apple may have seen some weakness in some of their products and they have to revise guidance, they're doing something similar to this and basically saying, look, we see a potential emerging issue. We have to call it out to the investors.
Sure. Quick question, Kevin. What program? Obviously, you're moving through a lot here, and this is very powerful. What program are you using to plot these forecasts?
So this is Minitab. I think this is version 17, and most statistical packages, whether it's R, SPSS, SAS, things of this sort, Python even, have time series analysis of some kind, and it's important to understand that a lot of these are just tools, but the interaction of the tool and the knowledge behind it is where the analyst brings the insight and brings the knowledge to bear. So whatever program you use, as long as you recognize kind of what is needed to understand the structure of a time series, then you can use pretty much any package.
Awesome. So before I let you go, how are we going to emerge into the next video? What will we be tackling?
So in the next video, we're going to talk about time series correlation, which well, you have talking about Nicolas Cage in the previous video. We're going to talk about something called spurious correlation. We're going to talk about why time series correlation is so difficult, and it's done incorrectly about 98% of the time. And we'll go through an example of things that may look correlated or not, but actually are not correlated or are. So we're going to go through some of those examples next time.
Excellent. Well, thanks as always, Kevin.
Hey, thanks again, Drew.